Welcome to KDAB Insights. Are you curious about the transitions from a C++ code base to Rust? In this video, we dive into the experiences of a RoboCup team from Hamburg that successfully made the switch. Discover their initial motivations for using Rust, the valuable lessons learned throughout the process, and how the team is currently benefiting from it. Let's listen to their story and learn why KDAB became one of their sponsors.
I'm Maxi from the Hulks, and we are a RoboCup soccer team. We are composed, we are students and competing in this World Cup and distributed all over the world. And the goal is to develop soccer robots, so humanoid robots. Also, some of them have wheels, but in our league they have legs and hands as humans do. And they do play soccer in actual matches, close to soccer rules, on a small soccer field. And we as a team decided to develop the entire framework and stack of our tools in Rust.
Hi, I'm Till with KDAB. I'm here at the RoboCup German Open, more specifically the Standard Platform League, where the Hulks from Hamburg are competing this weekend. So far so good, 2-1 in the first match. We were made aware of the Hulks because they use Rust. And although we are mostly a C++ consultancy, we have been quite interested in Rust lately, and more specifically in how people transition from C++ to Rust, the opportunities and challenges that they encounter. So it's been really interesting to us to talk to the Hulks and hear of their experiences. We're actually quite impressed by the challenges that they have been able to overcome, the way that they are able to onboard new members of their team because they have a constant influx of new members. And it's actually quite enlightening to see how a development team that can actually start from scratch, which is not something people can usually do out in the wild, is able to transition successfully from C++ to Rust.
Most of the other teams develop their robots in C++, or at least the code that is running on the robot. Most tools are actually also done in Python, but Rust is not that used very often right now. We were the first team that decided to try that out and in the end actually convert our entire code base to Rust. So our entire framework stack, down to the lowest level of our services running on our embedded Linux, are Rust, up until actually tooling to visualize things, to debug our robot while playing on the field, running on our local desktop machines, are all written in Rust. So the entire chain is written in Rust. That was not the case in the first place. So we also started in C++ and had some history in C++ as well. And over the time, more members of our team read about Rust and just thought, okay, that might be an interesting choice, or looks interesting. And as we are students, we are always curious of trying out things because that is not a production system. We currently can't break anything really. We have our soccer matches where we have to compete, and this should be ready, and we have to have a running framework on the field in the end. But we have usually roughly about a year of time of trying things and breaking stuff, and then it should converge somewhere in the end towards the RoboCup. And at first, we just tried out the language and looked at it, and with two people in the beginning, and we decided to just get a feel of that language by writing a tool that we use for debugging. And it was a CLI application, and we just used that up until now actually to deploy robots. So compiling the source code and shipping it to the robots and just copying via SSH and everything. That was the first tool we developed in Rust. And then it kept over quite quickly actually. Me and another colleague who were the central core of our framework team, we just decided, okay, that's such a nice language. There's so many modern concepts, new ways to think about it, an extremely good tool set of using the language while developing. So in our editors, there is Rust Analyzer as a language server, which extremely helps the development workflow. There's package management, dependencies and everything. And especially for RoboCup, where we maybe also share parts of our code with other teams, and also use, for example, just a little Kalman filter, which is already up there. It was so extremely easy to get that running in our system because we just ran cargo add and was there. And so previously it was a hassle of writing CMake files and everything. And so we very quickly decided, okay, I talked to Hendrik, my colleague, okay, let's sketch a framework in Rust and like think things new and try that out. And we came up with a prototype of just different threads running different nodes in our framework, because we have some distributed computing thing over multiple robots as well. And then we decided, okay, that it looks so nice, we want to continue. And then we had to actually convince the team. That was quite easy, because we had a situation where many people left the team because they finished their studies and new people joined. So they were new anyway. And so we tried out Rust as like writing robotics code, which is actually like when we switched, that was about 2020, was not like the most common thing out there. Like robotics code is not written in Rust. Like maybe nowadays there are more, but back then they were definitely not. Most of our code is structured in nodes, like doing their individual computation. For example, detecting a ball is individually. And we sketched a very rough running framework that only ran on the local machine. So the team were able to develop their individual nodes and port them from C++ to Rust individually and try it like locally before we actually committed to ship everything to the robot and develop on the robot yet. So we had some kind of the framework running on your local machine, modules ported individually. And we also had a lot of like expertise, which we had in C++ already. So we didn't develop the entire logics from scratch, right? We mostly ported things because they were already in C++. But yes, you probably also know, like when we read code and rewrite the code, that like gets different. And especially converting C++ to Rust made things so much easier to understand. Like maybe it's also because we just had to read the entire code again and understand what it does and rewrite it in Rust. But in the end, I think most high-level concepts, which we were usually not able to use that often in C++, made the code so readable. We didn't care a lot about performance, for example. In C++, there were so many thoughts about, okay, am I allowed to allocate this variable at this time? Does it like have some performance penalties or something? And in Rust, we actually, while porting, we never cared about that in the first place. We said to our student team, we said, like, just port it and do the best you can. And just don't think about performance. It's running on your machine anyways. And then like in the end, we shipped it to the robot and it just worked. That was really surprising to us as well, because it was so like as fast as our C++ code base. And by rewriting, we didn't care about performance, which we did a lot in C++. And so that was the process of converting from C++ to Rust. And now, like every tool and every service running on the robot as well is written in Rust. If we compete in a match, we usually have a preparation phase, and that gets quite stressful because you change some code and you want to deploy it in the last minute to the robot. And in C++, we actually converged to a like development workflow of not changing code, I think 3 hours before a game, which is a lot in RoboCup, because we were so afraid of running into segfaults, uninitialized memory, because many modules were so tightly integrated and connected that it may be also a software design issue, but we didn't know about that as well. But there are so many things you have to think about. If I like drop this variable, is it read somewhere else or something? And that never happens in Rust anymore. We gained a lot of confidence in changing things in the code. And if it compiles, combined with a rather huge CI workflow and test cases and everything, which we didn't also have in C++, so that also added a lot. But it's also integrated in Rust, so it's extremely easy to add it. That makes it very easy to make changes in the last minute, or maybe the last 10 minutes. Last minute maybe a very, very rushed situation. But we gained a lot of confidence, and we changed a lot of algorithms in the end, and that made it a lot easier to compete in RoboCup, because things get stressful anyways, and we gained some confidence in having the compiler making sure that things stay running. Like if you adhere to some basic Rust idiomatic things, then you're pretty sure that your service, for example, won't crash. Like you can go through your through your control flow and check that every variable is initialized in C++, but in Rust you don't have to, because it just makes sure that everything runs and stays running. And our robots have to stay running, because otherwise they will just drop out the game and we have one player less on the field, and that makes things very difficult for us. So that's I think the major change of like also having influence on the game actually. It makes Rust code worse if you have C++ code you want to port. So if we now have code, for example, from different teams nowadays, and they are all written in C++, so we want to adapt that algorithm to our world, we usually understand the code, the concepts, go to the whiteboard and like explore how it works and re-implement it from scratch, because like most of the proper idiomatic Rust things are not directly related to C++ idiomatic things. So that usually doesn't work for us as that good. So starting like from the idea and rolling that out in Rust way makes it much easier and like has a much nicer looking code in the end. But that also makes it difficult for Rust beginners because they are not used to Rust and not used to the idiomatic things. So for us was a lot of reading the publicly available code and everything that is like of the huge crates, for example. Maybe not the most complex, low-level compiler things, but there are some like well-maintained, huge crates out there, dependencies that you can just have a look at, and they have like good documentation maybe even, and then you quickly get used to ways you can express Rust. And I think the high-level takeaway is that if I explain to new students how to approach that, and they learn like C, for example, in the first semester in our university, they are used to think very low level. They think about memory, they think about allocations and everything. And in Rust, you can usually, like if you just develop some algorithm or some function, just abstract from that and forget about this and think about high-level processes and implement that in Rust functions that are available in standard library or in crates out there, and forget about all the technical detail about your computer. And that's, and in the end, it's fast anyway. That is really surprising. So I would recommend to think about high-level concepts, read about the high-level concepts in Rust documentation. There's a lot of there in the standard library already. There's some well-maintained large crates out there, which you can use, that are used by everybody anyway. And then just read a lot of code, I think, and get used to the language. When students start at our team, they usually know Python and C because they're trained in university to use these, maybe some Julia for scientific purposes, and they are not used to Rust. And over the time, we developed a crash course for Rust. That actually helps in, like, we need one single full day of work to get students just the brief overview of the language, the syntax. They know concepts from C already, like what a for loop is, for example, we won't have to explain. And our experience is that it's extremely fast to get them rolling in our production as well. We pair a lot with other programmers. So we do like usually letting the beginner program and the other one supervise and tell, okay, there's another Rust function you can use here, for example. And for me, it's really surprising how fast they actually are able to develop new things in our framework.